Hi children, we have completed exercise 1.1 sums in 10th class real numbers chapter. Today we are going to discuss about exercise 1.2 sums. So in exercise 1.2, already we know express each of the following numbers as product of prime factors. Already you are learning from 6th class, so I no need to say that one. Let us go for next one. Find the LCM and HCF of the following integers by prime factorization method. So here, what is LCM? What is HCF? See, in the textbook they clearly given what is HCF? Product of the smallest power of each common prime factor of the number. Product of the smallest power. That means we have to take common prime factors. They have given the word common. What is the meaning of the word common? I will explain you while explaining the sums. Here you see the word common. Smallest power. So these two you remember, okay? Common prime factor, smallest power. So that is HCF. LCM means product of the greatest power of each prime factor of the numbers. Here you have to say greatest power. So in LCM, you did not see the word here common. But here in HCF common, this word is there. In LCM we don't have the word common, only we have greatest power. So remember greatest power. Let us see the sum. First, find the LCM and HCF of 88 and 100. How to find the LCM of 88 and 100? First we have to write prime factorization of 88. Now already first Roman we have prime factorization, children. So how to do? Here you can learn that. In 2 table, 88 how many times? 44 times. First you write as product of prime factors. So we have to write, only we have to take prime numbers. 2 table 11 times. 11 table 1 time. So next let's go for 100. 100 is divisible in 5 table. How many times? 20 times. 5 table 24 times. 2 table 4 2 times. 2 table 2 1 time. So if you some members you may stop here. Whenever we get prime number you no need to write this step. That is your wish. So 88. How can we write 88? 2 into 2 into 2 into 11. Is it right? So I will write. How many 2's are there here? 3 2's. So we can write this one as 2 cube. In exponential form we are writing. Next 11. How many 11's are there? Only 1. So 11 power 1. Now 100. How can we write 100? How many 2's are there? First you see how many 2's are there? 2 2's in 100. 2 power 2. So how many 5's are there? 5 into 5. 5 squares. So did you understand? First we have to do prime factorization. Next we have to write the prime factors in exponential form. Now let's go to the definition of HCF. How to find the HCF? Here we are going to find HCF and LCM. Okay. How to find the HCF? What is the definition of HCF? Product of the smallest power of each common prime factors. So what we have to do? We have to take common prime factors. Common prime factors means you have to see what are the common prime factors here. Common base 2 2. So this is common base. So this one compulsory you have to take only common. In this common we have to take which power? Smallest power. So you see 2 power 3 2 square. What is the smallest power? 2 square. Is it right? So HCF equal to 2 square. Still anything there? If anything there we have to write into and we have to multiply with that. But here prime factor is 11. Here prime number is 5. Both are not same. So this is not a common prime factor. Okay. So what is the HCF of these numbers? 4. 2 square equal to 4. Now let's go to Definition of LCM. What is LCM? Product of the greatest power of each prime factors. Here we did not see the word common. But first we have to go for common. What is the common here? 2 power 3, 2 power 2. In these two, what is the highest power? Because LCM means what they told. If you see the word greatest power. In HCF, smallest power. In LCM, greatest power. So what is the greatest power? 2 power 3, 2 power 2. What is the greatest power? 2 power 3. So I have to write 2 power 3. Here we don't have the word common. So we can take extra. What is left extra? That one also. So here, what is extra here? 11 power 1 into 5 square. Okay. So 2 cube 8 into 11 into 25. So I have to multiply it. 8 into 25, 200 into 11. How much answer? 2200. Did you understand? So first of all, we have to see common base. In that, HCF means we have to take smallest power. Only common number, smallest power we have to take. LCM means we have to take highest power. After that, extra elements also we have to write. Extra, which numbers are there, which prime factors are left, everything we have to write. Did you understand, children? HCF means what? Highest common factor. That means these two numbers will be divisible. 88 and 100 are divisible in many tables. For example, 88 is divisible in which table? 1 table, 2 table, 4 table. Next, I'll show you just what is the meaning of 88. So 88 is divisible in factors you find. 1 table how many times? 88 times. 2 table 44 times. In 3 table 88 won't come. 4 table 22 times. Okay. Next 5 table it won't come. 6 table, 7 table, 8 table. In 8 table 11 times. So these are the factors of 88. Is it right? If you go for 100, what are the factors of 100? In 1 table it will be 100 times. In 2 table 50 times. In 4 table 25 times. In 5 table 20 times. Next 10. In 10 table 10 times. So if you see, both are factors. This is the factors of 88. These are the factors of 100. In these factors, 1 is the common factor, 2 is the common factor, 4 is the common factor. Still, yes. Still any common factors are there? No. So how many common factors we have? 1, 2, 4. 1, 2, 4. We have 3 common factors. HCF means what? Highest common factor. Among all the common factors, what is the highest common factor here? 4. Did you understand, children? Next, here, what is LCM? LCM means least common multiple. That means we have to write all the multiples of 88 and 100. In that common multiples you take. In that least common multiple you take. Understood? Next, let's go to next sum. Find the LCM and HCF of, I am giving connection sum. Find the LCM and HCF of greatest 3-digit number, greatest 3-digit number. Find the LCM and HCF of greatest 3-digit number and smallest 3-digit number. So this is one connection sum I am giving. So how to find the LCM and HCF of greatest 3-digit number and smallest 3-digit number? First of all, what is greatest 3-digit number, children? Do you know what is greatest 3-digit number? Greatest 3-digit number. Greatest 3-digit number is, what is greatest 3-digit number? 999. Okay. Greatest 1-digit number 9. Greatest 2-digit number 99. Greatest 3-digit number 999. Next you write smallest 3-digit number. What is smallest 3-digit number? 100. What is smallest 3-digit number? 100. So we have to find LCM and HCF of greatest 3-digit number and smallest 3-digit number. So first what we have to do? We have to find the prime factors of 999. It is divisible in which table? 9 table. But we should not take 9. Why? 9 is not a prime number. We have to go for prime numbers. 3 table. 333 times. Again it is divisible in 3 table. 111 times. Again it is divisible in 3 table. 3 3s are 9, 3 7s are 21. Now 37 is a prime number. It won't be divisible in any table. 37 once. Now 100. Already we wrote before in 2 table 50 times, 2 table 25 times, 5 table 5 times, 5 table 1 time. So what is 999? How can we write 999? 3 cube into 37 power 1. How can we write 100? 100 can be written as 2 square into 5 square. See here 3 times occurs, that's why I wrote 3 cube into 37 only one time there, so 37 power 1. 100 2 square into 5 square. Now let's go to the definition of HCF. What is the definition of HCF? You have to take common prime factor. Is it right? Do you see any common prime factor? Here base is 3. Here prime factor is 3. Here 37. 2, 5. Any common factor? Did you observe any common factor? No, we did not observe. Here we cannot observe any common factor. So what we have to write? HCF is 1. Why we have to write HCF 1? Because 1 is the factor of every number. If any common factor does not occur, then 1 is the HCF of the given numbers. Did you understand? Next, LCM. What I told LCM means first in the common highest power you have to take. Here in the common only not there, no. So what we have to do? We have to write all the terms. So 3 cube into 37 power 1 into 2 square into 5 square. You multiply and write the answer. Did you understand? You will get answer 99900. 99,900. Okay children, did you understand? Next, let's go to next sum. Find the LCM and HCF of 48, 144. Okay. So if you do 48, normal I am writing. If you do 48, what you will get? 2 power 4 into 3. You try children, already you know prime factorization. 48 can be written as 2 power 4 into 3. Next, 144. How can we write 144? 144 can be written as 2 power 4 into 3 square. 2 power 4 into 3 square. If you want, you check. Okay. Now let's find the LCM. HCF first. HCF means what? Out of common factors, we have to take smallest power. You see here common factor is 2. In this, what is the smallest power? Here power is 4. Here also power is 4. So the smallest power is, we cannot say because both are same only. No? So both are same. So we have to write only 2 power 4. Next, this is also common base. In this common base, what we have to do? We have to take the smallest power. Here, what is the first one? Power is 1. Here, power is 2. What is the smallest power among these two? 3 power 1. So, answer is 2 power 4, 16 into 3. How much? 48. Now, if you go for LCM, in the common, you have to take highest power. So, 2 power 4, 2 power 4. Same. We cannot say what is highest. Both are same. So we will write only 2 power 4. And here 3 power 1, 3 square. What is the highest power? 3 square. So only we have to write 3 square. For example, here if one more number into 7 is there. For example, if it is there here into 7, then for LCM we will write into 7 also. Because after taking the common, we have to write extra elements. Is it right? Okay. Now you multiply. 2 power 4 how much? 16. 3 square how much? 9. So 16 nines 144. Did you understand, children? So today what we learned? How to find the LCM and HCF of two numbers. Not only two, we can find, for example, if you want to find LCM and HCF of three numbers, for example, 8, 32, 70. If you want to find the LCM and HCF of these three numbers, 8 can be written as 2 power 3. 32 can be written as 2 power 5. 70 can be written as 2 power 1 into 5 power 1 into 7 power 1. See, this is the prime factorization. If you want to find HCF, what we have to do? Before up to now we find only for two numbers. No? Now in three numbers, what is the common? In three numbers, what is the common base? 2. In this, which one you have to take? Highest power or lowest power? Lowest power. What is the lowest power? 2 power 1. So we will write here 2 power 1 into anything there? No. So answer is 2. 2 power 1 means how much? 2. If you go for LCM, first in the common, you have to take highest power. What is the highest power? 2 power 5 into extra elements also we have to take. What are the extra elements here? 5 power 1 into 7 power 1. You multiply and write the answer. Did you understand, children? So today what we have in this already, okay, I forgot to say one thing. For example, suppose you got for some numbers, any number, for example, you got 2 cube into 3 square into 5 power 1. For example, if you are taking three numbers, 2 power 4 into 5 power 4 into 3, 7 power 2, for example. Next, here you got 11 power 1 into 17 power 1. Suppose if you do prime factorization, you got like this. Then how can we find the LCM, HCF? How can we find? First we'll go for HCF. HCF means what I told, these three numbers for example. So what I told, HCF means we have to take the common prime factor. What is the common prime factor here? Here 2 is there, here 2 is there. But we are finding the LCM and HCF of all the three numbers. So here 2 is not present, so we should not take. Here 5 is there, here 5 is there, but here 5 is not present, so we should not take. Okay. So here anything common is not there in all the three numbers. Common prime factor is not there. Not there means what will be the HCF? 1. If you go for LCM, see here, here we have common. We should not write 2 times. In these 2 times, LCM means what? Highest power you have to take. What is highest? 2 power 4. So 2 power 4 we will write. Next, here these two are common. What is the highest? 5 power 4. Still anything there? Not there. Now we have to write remaining what is left. 3 square into 7 square into 11 power 1 into 3 square into 7 square into 11 power 1 into 17 power 1. You have to multiply and write. If big numbers are there, we can leave like that. Understood, children? So what you understood here, how to find LCM and HCF. In HCF, we have to take common prime factors in that smallest power. In LCM, we have to take greatest power of the prime factor. If anything is not common, then one is the HCF. In LCM, what we have to do, in the common, what is the highest power we have to take, and extra elements also we have to take. But in HCF, only in the common factor, common prime factor, lowest power we have to take. Did you understand, children? Tomorrow I will explain how to check whether it is a composite number or not. Okay, children? Thank you.